All right, so we're going to start up on Module 11. We're going to talk, it's called performing ongoing database maintenance. What it boils down to is 3 different subjects that didn't really kind of fit in any other place, so they're not really all that connected, but they're really important topics. So we're going to talk about database integrity, what that means. We're going to talk about indexing, and we're going to talk about maintenance plans. So first, database integrity. We're going to talk about what integrity is, and then we're going to talk about using DBCC, which is an acronym. It's a program that stands for Database Consistency Checker. And we're going to check the database using that, and then we're going to take a look at what happens if you find problems. How do you repair corruption? So there are 2 different kinds of integrity that we worry about. There's physical integrity and there's logical integrity. Logical integrity is simply when the database, the pages in the database are out of order. It's not that big of a deal. Yeah, it's going to affect performance and we want to fix that, but it's not like we're losing any data. Physical integrity, on the other hand, is a problem. And it occurs as my disk starts to get older, it starts losing media, it flakes off. It's just a mechanical system, and as it starts to wear out, well, since all of our data pages are stored on that disk, as a sector or a cluster gets corrupted on the physical media, the data in there gets also wiped out. That's the real problem that we're mostly worried about. And that's going to be the emphasis of what we're talking about here. So we're going to use a program called DBCC and pass it a parameter called checkDB to do 2 things. First of all, test to find out if and what corruption exists. And second of all, to fix that corruption, maybe. Make more sense as we talk about it. So DBCC checkDB just simply goes through and checks all of the pages in your database, including the tables and the indexes, and looks for corruption, either logical or physical. If it finds corruption in either sense, it will tell you that it found it, it will tell you where it found it, and it will tell you what you can do to fix it. Now, some of the data corruption is very minimal, and DBCC checkDB can just simply fix it. You just run it a second time with an option I'll show you, and it repairs it. And we're done, no big deal. Some of the data, however, is lost, and DBCC checkDB can't fix it. The only thing it can do is delete that data and fix the pointers. And that's called repair with data loss. Obviously not something we would like to do. It may be a last option for us, and if it's the last option, and I mean the very last option, you don't have much choice, you're just going to do it. But if we've been doing our job well, we won't ever have to do that. Remember when we talked on Tuesday and Wednesday, we talked about backing up and restoring your database. And I showed you that you can restore a single page. And I showed you that you can query a table called dbo.suspectPages, which is in the MSDB database. And you can query it and find out any problems you have. So that's one way you can find out if you have problems. Another way you can find out is by running checkDB. Well, if you run checkDB and you have corruption, then the solution, if DBCC can't fix it, the real solution is to have the ability to restore that from a backup. But what if you don't know whether your backup contains the same errors or not? If you're not keeping track of this, then you don't know when the last time you backed up your database without those errors. So you don't know what backup to restore from. That's why I emphasized at the time, and I'll emphasize again, before you back up your database, whether it's a full or a differential or partial file group copy only, whatever it is, before you back up the database, you want to run dbcc checkdb. And don't bother with it for the transaction logs because that doesn't come into play. But for our database backups, if you're running checkdb before each backup, then you know that the backup you're looking at, last night's backup, for instance, is free from corruption. And then you can restore that page from it. Otherwise, you don't know, and you're going to be playing a guessing game. It will, at the very end, when you've run out of all other options, you can tell dbcc to repair it and lose data. Make no mistake, if it says that it will lose data, it's not being kind of pessimistic. It will lose data. And conversely, if it says it can repair this data with no data loss, it won't lose data. It's very accurate that way. But if it says you're going to lose data, you're going to lose data. And the problem is, you may not even know what you're going to lose. So if I haven't scared you enough by now, I hope I have, to make sure that you run checkdb before you do backups.
So Jeff, can I ask a question there on that?
Certainly.
If your backups are automated, would you put checkdb into that like as a step one? And if that gives you some error message back or some kind of indication, then don't run the automated backup? Or
Exactly.
Okay.
So now you can simply say, I'm going to go ahead and do the backup anyway, but at least I'm aware of it and I need to fix the problem tomorrow morning when I come in and then back it up again. That's kind of your choice. But yeah, definitely want to run this as part of your automation, and I'll show you how to do that. And so you can fix it so that if it errors out, if it has problems in dbcc, it simply won't run. Now, when you run dbcc checkdb, what it does is it takes a snapshot of your data to keep supplying requests, read and write requests from your database, so that dbcc checkdb doesn't have a negative impact on your performance for your end users. And that's all well and good, but to create a snapshot, you have to have enough disk space to hold a second copy of it. Not of the entire database, because it can do a snapshot of a portion, but you have to have a significant amount of free space on your disk. If you don't have that, you can run dbcc checkdb with tab lock. And what it will do instead of creating a snapshot, it takes each table one at a time, locks the entire table, so all transactions or all activity against that table are suspended. It does the checkdb against that table and then releases it and then moves on to the next one. So you can do that. It's not the best performance option, but it's an option if you're running out of free disk space. Another option you might have is you can tell it to do no info messages. Now, what happens when dbcc checkdb runs is it tells you everything that's okay. And quite honestly, I don't care. If it's okay, I don't really worry about it. So you see a huge multiple pages worth of screenshot of everything that's okay. If you run it with no info messages, it only comes up, and if there are no errors, it just says command completed successfully. If there were errors, then it lists just those errors, but it doesn't show you everything that's okay. Now, it doesn't run any faster. It's just a matter of how much information you want to get back. Additionally, it will only return the first 200 errors that it encounters. I mean, honestly, if you've got more than 200 errors, you've got a big problem and you're going to have to start working on this hard. But if you're on the phone with Microsoft support, they may ask you to run it with all error messages, because what's going to happen is they're going to get that. They're going to have you save it to a file and ship it to them. And then they can run it through some automated solutions and try and figure out what's going on. But you probably won't run all error messages unless you're on support call with Microsoft. Also, there is physical only to test just the physical integrity and not the logical integrity. I can't think of a good reason why I would want to do that. The logical integrity is fairly fast. It's not the slow portion of it. So I don't know why I would do that. Similarly, I can do it with no index. In other words, it performs the checks on the data, but not on the clustered indexes. Again, I don't know why you'd want to do that unless you were, it might save you a little time, but not that much. And so it's not something I do. You can go the opposite way, on the other hand, and you can do extended logical checks. So instead of not doing any checks, you can do extensive logical checks, and that's going to perform those logical checks on all of your indexes, your index views, your spatial indexes, your XML indexes, your clustered indexes, all of those kinds of things. So those are some of the options you might use. They're not all of them by any means. Now, when you run this, you're just going to say dbcc check db in parentheses and in quotes the name of the database, and then with any of these options that we just talked about. It will run, and at the very bottom of the output, if there are any errors, it will show up like this. CheckDB found 0 allocation, logical errors, and 4 consistency, physical errors in this database. And then the thing that makes your heart just stop, repair allowed data loss is the minimum repair level. Meaning, if you are going to rely on CheckDB to repair your data loss, you are going to lose data, period. This is the point at which you would better hope you have a backup that is known good, and you can then restore from that using the methods I showed you on, what was it, Tuesday, doing a restore database page equals, quote, the name of the page. Now, this doesn't show you the page number or page name that is going to be corrupted. That's when you would go use msdb.dbo.suspect_pages to find out the exact database ID, file ID, and page ID of what's corrupted. Okay, so we have a database that is purposely corrupted, corruptDB. If I select from it, or let me actually do this, select star from msdb.dbo.suspect_pages and execute that, it's showing me that, wait, why? Huh, that's interesting. Huh, I don't know why that's not showing up. Because if I run dbcc check db against corruptDB, I'm sure I will have errors.
You're on localhost. Do you need to be pointed up to the other server?
I don't think I do. We can check that. Let's see here. Yeah, okay. So this is finding 4 errors here, just like it showed you in the slide. But I don't know why this is not returning any suspect pages. Oh, there it is. Interesting. Okay, well, now there they are. Now this is at the point at which you would want to, if you had a good backup, you would want to restore database, corrupt DB, which is like the name of the database, page equals quote, and you take the file ID and the page ID, so 1:283 from disk equals wherever your backup file was. And that would be the right way to go about it. So if I run CheckDB normally, I'm going to capsize this. You can see it takes a long time, and remember, AdventureWorks is only about 200 megabytes. So in large databases, a couple of hundred gigabytes, this can take hours. But you'll notice here are all of the things that are okay, and you scroll down to the very bottom, and you see 0 allocation errors, 0 consistency errors. We're doing the same thing with no info messages. It doesn't run any faster. All it's going to do is eliminate all those messages about everything that it checked that was okay. And it's just going to come back with commands completed successfully. There were no problems. On the other hand, if we run CheckDB against CorruptDB with no info messages, it's a much smaller database, so it should run faster. We do have problems. And it shows us the table error, our index ID, allocation ID, the page number, 1:283 is a problem. And again, another page here, page 309. 310 is missing a reference. There's a lot of interesting information in here. But notice the heartbreaking message, repair allowed data loss is the minimum repair level. And at this point, if you don't have a backup, you're in real trouble. You're going to lose data. Now, normally when we have a database with corruption, we don't know where it is. We know what page it is, but what table is that? What data is that? In this case, because this was purposely corrupted, we know exactly where the error is. So we're going to select from corruptdb.dbo.orders. And we're going to get back this error message. This is the error message your users will see. And if you look carefully, it says it occurred during a read of page 1:283 in database ID 18 at offset such and such in file right there. It tells you all that you need. There's just one problem. It has some hex code here. And the minute your average user sees that hex code, they stop. It's like a mental block comes up. They see that and they go, oh, well, I can't understand that, so I give up. So here's what most people are going to do. They're going to close that error, and then they're going to call the help desk, and they will say, hey, I was reading the dbo.orders table, and I got an error. Well, what was the error? I don't know. It said something about some hex code or something. All that valuable information that was passed to you is lost. This is why, as developers, if you're doing that job, you should trap your errors and return more intelligent or more helpful error messages than ones like you just got. Because, any error message you pass to a user should not contain hex code, and if it does, it shouldn't contain it up front. It should contain something friendly that will allow them to keep it up there, call the help desk, and pass on the valuable information. Unfortunately, our user didn't do that. They just called and said there was a problem. Now, because we corrupted this database on purpose, we not only know what table it's in, we even know which records were corrupted. That's not real world, but I wanted to show you this. If I select from this, where order ID equals 10400, I still have good data in that table. That record is not corrupted. But if I select star, it encounters some corrupted records and quits. This is the point, like I say, what we should do is restore from backup. If you can't restore from backup, then you're into the oh no phase. So what we need to do is repair the database. So we're going to alter the database, set it in single user mode, because it needs to be there for us to repair. And we're going to roll back immediate. We talked about what that means. And in this case, I wouldn't have any qualms about doing that, because anything anybody does is just going to make the problem worse at this point. So I roll back any transaction, set it in single user mode, and then we're going to run dvcc checkdb in parentheses and in quotes the name of the database, comma, repair allow data loss. That's my admission that I'm giving up. I know that I'm going to lose data. And then I put it back in multi-user mode. So we'll do that. And notice the message comes through. And it says it found 4 consistency errors in the database, and it fixed 4 consistency errors. Now, if you want to get specific information, you can scroll up here, and you will see if we can find it. Here we go. Right here, where it found those errors. 788 rows in 19 pages for the object, the table named orders. It found those errors, it fixed those errors. It up here it's saying the error has been repaired. It's getting specific about the individual errors. But the fact is it's all fixed now, and we can prove that to ourselves by selecting star from it, and we get back our data. We get back 788 rows. Here's the problem. We know we lost data. What data did we lose? Well, there is no way to know. There's nothing in here that will tell us you lost this record, because guess what? It was corrupted. It couldn't read it to tell us what record it was. I suppose it could have given us all the jumbled stuff that was in there, but it can't read it, so it can't tell us what was lost. Now, if I run checkdb against it, again, now it should be fine. It is. So all my problems are fixed, but I know I've lost data. Now, in this case, we know that the orders table is a primary key table, and the order of details table has a foreign key pointer to it. By the way, this is why you never create tables with spaces in the names. Because from now on, when you refer to them, you have to put these silly brackets around it. Anybody who makes a table with a space in the name should be taken out and flogged or something. I don't know, something bad should happen to them. So since we know that there's a primary key, foreign key relationship between these tables, we can assume, and it's not 100%, but we can take a good guess, that there are stranded records in the foreign key table that are associated with the records that we just lost. Now, it is possible that there was a record in the orders table that did not have an associated record in the order details table. Given the nature of these two tables, it's unlikely, but it is possible. So you can't take this as a 100% way of doing it, but you can do this. I'm going to select from order details table where there is not a matching record in the primary key table. And when I do that, I get back 42 rows. Now, I know that there are at least 42 orders that were erased, that were lost. There could be more, but at least I can go back. If I have some kind of paper trail or some other way to track down the information in these orders, 10248, 249, etc., I can at least begin to rebuild that data from some kind of paper trail. Any questions about CheckDB? Okay. This is the thing that you hope you never encounter. And if you ever encounter it, don't call me, because I'll be embarrassed. I'll be ashamed of you. No, I won't. I'll help you if I can. But hopefully, you'll never have to encounter that. All right. Let's change gear and talk about maintaining indexes. So before we get into any of this, I think that a little background on what an index is will be helpful. So we have two kinds of tables in this world of SQL Server. One is called a heap, and that is a table with no clustered index. There's no clustered index on it. We also have tables that are called B trees. And that is simply a table with a clustered index. Now you will occasionally, oops, sorry, I didn't mean to make you sick there. So we have heaps and we have B trees. You will occasionally see a reference to something called a hobbit. And that simply stands for heap or B tree. In other words, it's not an acronym, it's a word, it's a descriptor that describes tables without any reference to whatever indexes they have. So if you see hobbits or hobbit ID or those kinds of things, just realize it's talking about tables generically. Now, let's talk a little bit about a heap. A heap, since it has no clustered index, there is no guaranteed order to the data. It may change from minute to minute. So if I have a heap and I insert 10 records and they're inserted in a certain order, I will not necessarily get them back in the same order when I select from that heap. The order of the data is not guaranteed, it's not predictable, it changes with the way things move around on the disk, etc. A B tree, on the other hand, which does have a clustered index, there is a guaranteed order to the data. Now, I may do a select statement with an order by and subvert the natural order of that data, but there is a natural order to it. And if I select from it and no other indexes or order bys come into play, it just does an actual read, it can read from that data from top to bottom, and it does it in such a way that the data is returned ordered by whatever your clustered index is ordered by. Now, to understand the difference between a clustered index and an index that exists on the table but is not clustered, I'm going to give you an analogy. When I was in high school, I took a class, I took an American history class. We're going to be honest with you, it was because there was a cute girl in the class. That's the only reason I took it. But I did take it. And they gave me a book. Now, surprising. And also not surprising, when I opened up that book, one of the first pages was a table of contents. Also not surprising, the table of contents was in chronological order. So the first chapter was, Columbus discovers America. Second chapter was pre-colonial America, then colonial America, then the War for Independence, etc. And it was all listed in chronological order. Now, imagine how surprised I would have been if I opened up the first page and it started talking about World War II. No. The pages of the book were ordered according to the table of contents. Just like the pages, remember we have 8K pages, the pages in my table are ordered according to the clustered index. So if I have a clustered index based upon, I don't know, the business entity ID column, then I would expect that the pages in the table should be in that order. And in fact, they are. That's the definition of a clustered index, is it physically sorts my data according to the index. But going back to my analogy, in the back of that textbook, there was another index. It was an index based upon people and events alphabetically, not chronologically. So at one of the first entries in that alphabetical index might have been Adams, John. But one of the last entries might have been Washington, George. Now we know that chronologically, George Washington and John Adams were contemporaries. They would be on the similar kinds of pages, but alphabetically, they're worlds apart. Now, in my history book, if I want to read about John Adams, I would look at that index, I would find John Adams, John, and it would say John Adams is discussed on pages 12, 27, 34, and 35. And you've all been there. You know what you do. You put your finger in the index, you flip back to page 12, and you start reading until it's no longer talking about John Adams. Then you go back to your index, and it says page 27. So now you flip to page 27. You read about John Adams until it stops talking about him. And you keep going back and forth between the index in the back of the book and the pages where the data is until you've read it all. Well, that's exactly how a non-clustered index works. The non-clustered index does not arrange the pages of data. They are according to the clustered index. The non-clustered index is a separate thing. It's still in your MDF and NDF files, but it's a separate area, and it has pointers back to the pages where this data exists. And I flip back and forth. So SQL Server, if I do a select on a B tree with a where clause where last name equals Adams and first name equals John, it goes through and looks through my non-clustered index to find Adams's, and it starts reading there. And that's how it finds it. Obviously, a clustered index is going to be a faster read than non-clustered index. Because if I had taken my history book and set the table of contents according to alphabet, I could have easily gone to the page that starts with Adams, John, start reading until I'm reading about, I don't know, whoever else comes along, you know, whoever the next person is. And I know I was done. Same thing with a clustered index. I can know exactly what page Smith starts on. I can go there and I can start reading until I read the first one that is no longer Smith. I'm done. So clustered index provide for me a much faster read than non-clustered indexes. There are two disadvantages though. Number one, a clustered index, you can only have one of them. I mean, honestly, you can only arrange the pages in one way. So you're limited to one clustered index. You can have as many non-clustered indexes as you would like, up to, I believe the limit is 1,024, but if you even come close to that, something's really wrong. If you've got more than 10 non-clustered indexes, you need to be asking yourself a question about what's really going on here, because it is not right. The other disadvantage of a clustered index is it reduces or hurts your write performance. It increases your read performance, but it hurts your write performance. Now, let me show you why I say that. With a clustered index, we have my pages. Now, at the first page is called the root index, or you'll often hear it called the I am page. I am stands for index allocation map. And the I am page contains a list of all of the other pages and the records found on them. Now, in a smaller table, this one I am or root index page can contain a pointer to every possible location. So it would say Adams's start on this page, Baker's start on this page, Roosevelt's start on that page, Washington's are on that page, etc. That's all well and good, but how big is this page? Anybody remember the size of that page?
So it's 64, okay?
No, that's an extent.
Oh,
8K.
But the individual page is 1/8 of that, or 8K. That means it can only contain 8,000, roughly 8,000 pointers. They say roughly because there's some header information and that kind of thing, but roughly 8,000 records, pointers. If you have more than 8,000 records, it can't contain all of them, so it creates these intermediate pages. So now it would say A through C is found there. D through L is found on this page, and M through Z is on that page, or whatever. So you would ask for Adams, it would say, oh, I don't know, but go ask this page. This page would say, oh, Adams is found right there.
So this is for non-clustered that we're...
No, this is for clustered.
Okay. The caption says clustered index and non-clustered, so I wasn't sure which.
Yeah, and actually,
the diagram.
the thing I just said would be true of either clustered or non-clustered. But specifically for clustered, I have this problem. And that is, if this represents, they talk about the leaf level, and they also call it the data level pages. This is where your data physically resides. So let's picture that all of these pages, of course, are 8K, and they're all full. And I need to insert a record, and it's supposed to go right there. What am I going to do? Well, with a non-clustered index, I would just put the record up. I just create a new page and put it at the end, because there's no order to it. But with a clustered index, it has to go right where it's supposed to. So what I would do is I would create a new page, and they call that act a page split. Page splits are bad. And it's not they're horrible, you have them all the time, but the fewer of them you can have, the better. So it would split the page, it would create a new page, it would take some of this data and move it onto this page, leaving up room so that I could insert my new record right where it's supposed to be. But that's not the end of it. It now has to do two more things. First of all, it doesn't show it in this diagram, but each page is linked to the next page in order. That's where we talk about logical consistency. Well, this link right here has to be broken, and a link has to go from here to this new page and from the new page back to that page. And then, as if that weren't bad enough, it has to go up to either my intermediate pages or my root index, or sometimes in really particularly unfortunate events, it does both. So it has to adjust these pages. So it might be, it's unlikely, but it might be this record was sitting right on the edge of this intermediate page. And so when I split this page, it has to actually go up and adjust the root index page as well. That's not common, but it can happen. But either way, this whole page splitting thing is costly in terms of time and CPU and disk and all those resources. We would like to avoid that. I'll show you how. Before I show you how, I need to explain index fragmentation and that there are two kinds. One is when my pages are not in the right order. Does that sound familiar? When we talked about DBCC check DB, remember there were logical errors and there were physical errors. These are the logical errors. And later on, I'll show you how to fix those. It's pretty simple. That's called external fragmentation when the pages are out of order. It's easily fixed by reorganizing your index. Easy. Internal fragmentation, however, is not quite so easy. We can still fix it, but it's not quite so easy. Internal fragmentation is when my pages are not completely full. In other words, going back to this diagram, it's when some or all of my pages are only partially full. Well, you know what? That's a good thing. If I'm going to be writing to this database, or this table rather, I would like the pages to be less than full to avoid that very problem we just talked about, having to do page splits. So what we would like to do is discourage this external fragmentation and encourage internal fragmentation. It's a good thing. So I'll show you how to do both. But just before I do that, I want to show you how to detect fragmentation. So if I take a look at this database, I can right-click on it and go to reports. One of the most commonly forgotten benefits out of this are these reports. These reports are fantastic. You can see all sorts of stuff: disk usage by tables, transactions, all this kind of information, top transactions by locks, top transactions by age, et cetera, et cetera. But down here there are two reports about statistics. One is index usage statistics and one is index physical statistics. Usage statistics is a very interesting report, gives us lots of information and helps us see if we have indexes that are not being used very often. If they're not being used, they may be a candidate to get rid of them because every index has to be maintained and that induces overhead. So we can take a look at that, but for our purposes, this discussion, we're going to look at index physical statistics. And it will bring up this report. Takes a little bit of time to load on a larger database. And I will tell you that for this database, there's been so little activity, we're not going to get very interesting information out of here. But we could take a look at, for instance, in the human resources.employee table, this index, it's recommending that we rebuild it. Well, let's take a look at it. If I expand the number of partitions, I see there's one partition and it's 67% fragmented. Oh boy, that's horrible. We'd better stop and deal with it. Well, wait, slow down, maybe not. How many fragments are there? So this one particular partition for this index is fragmented into 3 fragments. That doesn't sound so bad. The average number of pages per fragment, there's only 1 page in each fragment. In other words, if you picture it, if this is a picture of my page or of my index, it's got 3 pages. One of them is out of order with the other one. Oh, big fat hairy deal. That's about as meaningless as they come. So you can't just look at this number and react to it. You have to look at that number in conjunction with the number of fragments and the number of pages per fragment. You know, if there are 14,000 fragments, yeah, then that would be a big deal. But 3 fragments are not even going to take time to think about it. It's nothing. So don't let the average fragmentation percent catch your attention, at least not only. Well, how do I deal with that fragmentation? So I'm going to create a table just to show this to you. So I'm going to create a table called phone log. And I'm going to insert some data into it. So we're inserting 10,000 records. So it's taking a second. There we go. Now there is a function called sys.dmdb_index_physical_stats. Sometimes I think they get paid by the number of letters in the name of the object they create. And I'm going to use that function, excuse me, against the phone log table that I just created and get a detailed report about the index statistics. And what we're really looking for are a couple of things in here. First of all, the index depth. Remember that diagram where we had the I am page, and then we had data pages out here, and then we had the possibility of intermediate pages. Well, index depth of 2 is telling me there are 2 levels below the I am page or the root index page. In other words, this exact scenario. That is great. 2 index, I mean, you can't hardly hope for 1 because then your tables are all really tiny. Most tables, this one has more than 10,000. So we have 2 levels below the root index or I am page. That's great. If you start seeing more than about 4, then something may be seriously wrong, and it's probably nothing to do with the fragmentation. It's probably to do with database design. Because if you think about it, each of these intermediate pages are 8K, so they can only point to 8,000 of these pages. If you have to have another level of intermediate pages, you're 8,000 times 8,000 times 8,000 times 8,000. Now, either this is just a plain extremely large table or somebody's designed it poorly. But an index depth of 2 or 3 is great. That's not really what we're looking at. Look at the average fragmentation. It's 3.5%. Great, it's nothing to think about. And there are 5 fragments. And there are about 11 pages per fragment, 56 altogether. And the average page space used is 99%. In other words, each of my pages are almost completely full. Now, let's rearrange, let's mess up that data. This is going to take a little bit to run, so I'm going to start it. And basically, I'm just moving everything all over the place. So I'm going to let that run. While that's running, are there any questions? Okay. All right, so it rearranged all of our data, updated everything. Everything got moved around. So now when we recheck that fragmentation, we see a different story. We see, whereas it used to be, what was it, 3.5% roughly fragmented, now it's almost 90% fragmented. There are 200 and some fragments, and the average fragment is just a little over 1 page. That's not good. Okay, now that is a problem. That's going to have a very negative effect on querying this table. So the way I fix this is I am going to rebuild my index. Now, there is rebuild and there's reorganize. It's a matter of degree. Rebuild is extreme. It's basically going to throw away the index and create it from scratch. Reorganize is less extreme, but it doesn't do as good a job. I think of it this way. If we're sitting at home one night and a neighbor calls up and says, hey, we're going to drop by and say hi, we go into a little bit of a panic, and I bet you do too, right? Suddenly my wife is making me take all the magazines off the table and take them up to our room. All the shoes have got to be organized in the entry, you know, on and on and on, as if the neighbors believe that that's how we live every day. Yeah, that's just a little falseness that we live with. But it's not that big a deal, because when they leave, I go get the magazines, bring them back, put them on the coffee table, the shoes get kicked around, you know, that kind of stuff. The dust starts building up again. But if my mother-in-law comes to town, it's a whole different story. I mean, I'm repainting things, you know, we're looking at the floor. Should I resurface the floor? You know, it gets insane. Well, reorganize is like when the neighbors come over. Rebuild is like when the mother-in-law comes. Right? That's the best analogy I can think of. It's just a matter of degree. So I would recommend, in a normal world, you rebuild your indexes rarely and you reorganize your indexes frequently. Now, that doesn't help a whole lot, I realize. So I can't tell you what that means in terms of really how often. But let's say, for instance, you rebuild your indexes once a week, and maybe you reorganize your indexes every night. Or maybe if you find that's not quite sufficient, you rebuild your indexes once a night and reorganize them once or twice throughout the day. You're just going to have to play with it and get a feel for how often that needs to be done.
So can I ask a question about that?
Absolutely.
So, what do you base the decisions on? Is it like by running a profiler every night, or is it based on like the day's queries that have come through and you're noticing some degradation? I mean, what would make you decide, okay, I need to rebuild once a week or reorganize every night? What's the basis for making those decisions?
Great question. And it comes back to a query like this. And so here's how I approach it. I start off by rebuilding every Saturday, or, you know, whenever I do my full backup. After that full backup is complete, I rebuild my indexes, and then I reorganize them every night. But I keep an eye on the fragmentation as it goes throughout the day. And if I find that I'm getting radical fragmentation 3 or 4 times a day, then I might step that up and rebuild every night. Or what I might do is just reorganize 2 or 3 times throughout the day and see what happens. If I'm reorganizing 3 times a day and it's still not getting there, then I will switch and rebuild every night. That's a big process. But remember, we're talking about a table, not a database. So you will have some tables that never get fragmented, or rarely, and some tables that are very active. I'm doing a lot of reads, a lot of writes, a lot of inserts, updates, that kind of stuff, and I have to reorganize them or rebuild them more often. So it's mostly about how often the fragmentation occurs, and that you start with doing it rarely, and then only increase if you need it, because it does have an overhead, and it's not an insignificant one either. So try to do it in off hours. Okay, I don't remember if I ran this, so let's do it. Let's rebuild that index. And notice I'm altering the index all. I could rebuild just a particular index, I would, what database? I would, am I still in Data AdventureWorks? Yeah. So I would take a look at these indexes. In this case, there's only the one, but you could decide that I need to be rebuilding this index quite often, but other indexes not all that often. If I alter index all, it will be, in this case, it doesn't matter because there's just one, but all would indicate all the indexes, or I could alter index and this name here. That's a horrible name, by the way. That's what you get when you create a table and don't specify the names of your indexes. That kind of machine-created name. All right. Now that I've rebuilt it, let's check our index fragmentation again, and we should be back to closer to what we were. Now, one word of warning. You're seeing in the lab here, average fragmentation after a rebuild is back to 0. Don't expect that in the real world. 0 fragmentation is certainly possible, but it's not common. Even at the second after you rebuild your index, I wouldn't assume there would be 0 fragmentation. There might still be, 3 to 5%, which is just nothing to worry about. But also notice we're back to 1 fragment because there's 0 fragmentation and 161 pages in each fragment. So we're in good shape. Questions about that? All right. So that tells us.
Question.
Yes.
What happens if it generates an error rebuilding the index? What do you see?
You would get back a specific error number, and the most common error that you would get when you're rebuilding your index would be out of disk space error, in which case you know what you got to do.
Yeah, you better never get there.
Yeah, you better never get. I don't remember very often getting errors in indexes.
Okay.
Not in rebuilds anyway.
All right, thank you.
You're welcome. Okay, so that was the external fragmentation and how you get rid of it. But how do I encourage internal fragmentation when I want it? When I create my index in the first place, or when I either rebuild or reorganize, I can establish what's called fill factor. And fill factor is the percent that each of the pages are full. So fill factor equals 70 means each of the pages will be 70% full, 30% empty. And now there's room to check and see, what's going on here. And if I need to insert a record, I probably don't have to do a page split. Maybe you have to rearrange some things on the same page, but that's not much effort. So I can, when I first create the index, like in this case, I'm creating the table, or actually in this case, I'm altering the table, adding a constraint, a primary key constraint, which creates a clustered index. And I'm just simply saying with fill factor equals 70. Don't worry about pad index. We'll come back to that in a minute. That means each of my pages are 70% full. Now, it doesn't maintain that. As it goes throughout the day, those pages are going to get more and more full as you insert more data. So as you insert more data, the amount full that those pages are will increase. Now, the perfect utopian world would be where the very last insert of the day made my very last page 100% full. And then I would rebuild it, establish 70% again, and every day the very last transaction would fill up my pages. That's not realistic. I don't live in that kind of utopian world, and I hate to put it to you, but you don't either. So we get as close to that as we can. Now, I have found as a starting point, 70 is a good starting point. And you'll have to determine how much effort you're willing to put into this, because it can be a big deal. But if you're willing, if this table is worth the effort, here's what you do. You set it to 70. And several times throughout the day, you go run that query that I showed you, the sys.dmdb index physical stats. And you will see the percent full that the pages are, the average percent full. And you're hoping to see it be less than 100% full all day long. And as you get towards the end of the day, you know, it'll probably be in the 90s. Great. On the other hand, if it gets to be noon and it's already 100% full, then you need to leave more empty space, so you would lower this down to 60. Or the opposite, if it gets to the end of the day and there's still plenty of free space, well, you're wasting disk room, so you might increase the fill factor to 80. I have seen fill factors as low as 30%. In other words, these tables are just constantly written to, but usually that is in an environment like an assembly environment where data is being inserted by an assembly line. As widgets come off the assembly line, it writes into the database. That's not normal. I'd say 70 is a good average. So if you don't know better, start with 70. And if you don't have time to really test this all day long, let's be honest, we've got a lot of work to do. And if you don't have time, well, then 70 will probably be fine. But you can always adjust it up or down depending on what your needs are. You can, by the way, alter indexes online. Don't do it if you don't have to, because it's going to slow down everything. The rebuild of the index will be very slow, and the access to that data will be very slow. But if you're running in a 24/7 operation where you have an SLA requirement, the data must always be available, well then you can do it. You just simply put, you know, your pad index, fill factor, and online equals on. Now, you fulfilled your SLA, not sure it was what you wanted to do, because it will be radically slow to where it may even feel like it's not working, but it will be working. By the way, I forgot, I was going to mention pad index. So come back to this. In fact, come back here. Remember our intermediate pages? They also can get full. They get full at a much slower rate, but they can get full and have to split. And so pad index just simply says, if you turn it on, those intermediate pages will have the same fill factor as your data pages. Generally speaking, I leave it off because they fill up at such a slow rate. Why waste that disk space? But it's up to you. We've talked about statistics. And remember when we talked about creating a database, we talked about the options in a database. And we talked about the automatic options, and there were some for creating statistics and some for updating statistics. Well, you can issue a command. You can either issue the T-SQL command update statistics or execute the stored procedure. That's going to update all of the statistics in your entire database. Think carefully before you do that. If you have the update statistics turned on, you should never have to do this. But remember, statistics are radically important to the performance of your server, so you definitely want to keep the update statistics turned on. Questions about indexes?
On the update statistics, is that at the database level or the server level or the table level?
The database level. Now you can manually go update statistics on a table, but the auto update statistics is a database level option. And I would really strongly urge you to leave those automatics exactly the way they are in their default settings. I wouldn't change those unless I really, really, really knew what I was doing. A friend of mine, a mentor of mine, a guy named Glenn Wooden, who's one of the all-time geniuses at SQL Server, was giving this great lecture one night on statistics, and we spent a long time pouring through detail after detail where my head was starting to hurt. And we were talking about updating statistics asynchronously versus synchronously and all this kind of stuff. And eventually one of the people in the audience said, well, Glenn, when do you do that? And he looked at him and gave him kind of funny look. He said, I never do it. I always just leave the auto set on. Why, well, this is just for fun. This is just geek nerd talk. I would never actually do it. I had to laugh. I thought, great, I spent a whole evening of my life listening to something that I'll never actually use. But that happens quite often. All right, last thing I want to show you, and I think I'll skip the slides for this because it's faster just to show you because it's pretty quick. I'm just going to show you maintenance plans. Now, I can't remember who it was, but I know that one of you specifically mentioned that maintenance plans were an issue you wanted to talk about. Who was that?
It was me, Kip.
Okay, Kip. So here you go. So under management, we have maintenance plans. And I don't think I have, no, I don't have any running right now. So we're going to create one, and after I create one, I'll come back and show you what we've actually done. So I'm going to right click, you run the maintenance plan wizard. The first worthless wizard page, I always say, don't bother showing me this again. Click next, and we'll give it a name. So this is going to act as kind of a pop quiz. So let's do this. I'm going to create a maintenance plan that is going to do a full backup of AdventureWorks. Now, I can create a schedule for this. I can create a schedule for each task independently, or I can create a schedule for the entire plan. Now, I'll click this. I'm guessing that you've probably all seen a dialog box like this, and I don't need to explain it. If I do, please let me know, but I'm not going to bother because I'm thinking that you probably already know how to use this dialog box. But of course, when I put it that way, it's kind of like nobody's really stupid enough to ask me that question, is it? It's not what I meant to imply. If you don't know how this works, let me know, and I'll be glad to explain. But I can set up a schedule. Now it's saying, of these tasks, what do you want to do? Well, remember, one of the things we're going to do is we're always going to check the integrity. And then we're going to back up the database. We'll do a full backup. I also want to reorganize my indexes. And I don't know what else. Let's just throw in update statistics for fun. Not that I really need to, but we'll just do it for have something else in there. Those are the things I want to do, but that's not the order in which I want to do them. So here, I can rearrange them. So I want my integrity check to run first. Then I want my backup to perform. And then reorganizing and updating should go in that order. So I've got them in the order I want. And now I'm going to walk through for each of these 4 options. I'm going to walk through a series of dialog boxes. The first one is on check integrity. Now this is going to be on every one, so I'll just explain it once. I can say check the integrity on all databases. Boy, I hope you have a long period. All the system databases, all the databases except the system databases, or just specific databases. To save time, I'll just have it do AdventureWorks. Next dialog box is on backup. I'm not going to spend any time here because we have covered this thoroughly already. I'm just going to tell it to backup AdventureWorks. I would, fill out the rest of this stuff, but we'll just leave it default because you already know what this all does. This is exactly the same as the dialog box you would get if I right-clicked AdventureWorks, went tasks, and went backup. And we've already covered that. Then's my reorganize my indexes. Again, which database? And do I want to do it on my tables and views, or just my tables, or just my views? To make this run fast, I'm just going to say views. Although in the real world, I'd probably say both. And then I can even select individual ones. I'll just do all objects rather than, because it'll run really fast. And finally, we've got the update statistics again for this database. And I'll do it on all tables and views, although this operates the same as what we just saw. And then update, do I want to update all the existing statistics, or just the columns, or just the index statistics? I'll do all of them. Click next. And then it's saying, when this is all done, do you want to write a report? Yes, I'm going to have it write a report out to this file. I could also have it email that report to someone. I don't have database mail set up, so I'm not going to do that. I'll click next. And
Does that question, database mail, does that mean you have to have a separate mail server set up on your database server, or can you just use a generic SMTP server?
Now you can use a generic SMTP server. Early versions of SQL Server, you actually had, it required you to use Microsoft Exchange, and you, believe it or not, you had to install Outlook on your database server. And every DBA in the world said, no, not in my lifetime. So they never used it. So in 2005, they changed it. It's a very simplistic generic SMTP installation.
Okay, thank
But I
you.
will show you in the next module how you set up a database mail, because it's not on by default. Okay, so we've done this. Now what I'm going to do is kind of surprise you and show you what that maintenance plan is. Let me refresh this. There's my maintenance plan. Now, look down here under SQL Server Agent Jobs. There is a job associated with that maintenance plan. This is how I schedule it and run it. We'll do jobs in the next module. But watch this. If I look at this and I modify this maintenance plan, you tell me what this really is under the hood. What does it look like?
It's not like SSIS, doesn't it?
Yep.
Yeah, I was going to say the same thing.
It is SSIS. In fact, if I look at this job and look at the step to run it, it is a SQL Server Integration Services package.
Now, do you have to have that special version of Visual Studio installed in order to get that SISS interface to pop up?
You don't. It's all in Management Studio, and so it will show up. You wouldn't be able to use the SSIS tools to modify it if you didn't have that installed.
Right.
But it would create it. You could see it. You could make changes here. This is a simplistic way of making SSIS changes.
Right. That looks just like more a viewer.
Yeah, exactly. It is a viewer. If I need to make changes to this, I'll just actually open it up in SSIS and make the detailed changes there.
Very cool.
That's all a maintenance plan is. And now I can schedule this and it will run, or I can right click on it and have it execute right now. I won't bother, but I could have this run right now. And that's all a maintenance plan is. Now, come back here. And take a look at some of the things we didn't include here. Shrink database, how often should you do that? Never. It was a trick question. Never, never, ever do that. Right? But look at the other things you can do. You can have, in your maintenance plan, have it execute another SQL agent job. You can do full differential and T-log backups. You can clean up the history of this. So if it's left a bunch of files sitting around, you can clean it up. There are all sorts of things, reorganize and rebuild indexes, etc. There are a lot of things you can do in here. And if I can take a look at SSIS, I still happily do. I'll just use this one we created earlier, not that we're actually going to use it. I just want to open up a package to show something to you. In the control flow tab of SSIS, there are other tasks, and if I expand that, look here, there they all are. They're even called the maintenance tasks. So you could include those same tasks in any SSIS package. So any questions about DBCC CheckDB, about indexes, or about maintenance plans? All right. Well, let's take a 10-minute break, and we'll come back and we will talk about the final module.